Yeah. Numbers went down in COVID and we went online. We were getting about 80 to 100 people online, but nobody in here. So I'm delighted that we've got about 30 in here. And John has just said we've got 64, 80. We've now got 80 online. So the numbers are building up. So thank you very much indeed for attending tonight. And I'm delighted to introduce Greg Harris tonight to give us our talk on the River Don engine. And I'm assuming that you've all seen the River Don engine, probably in operation. And this is quite a nice talk that Greg's put together on the history of the engine and some of the mechanical engineering of the engine. So thank you, Greg, for coming along. Let me give a little bit of background to Greg. Greg has given me this CV. One of Greg's pleasures during his teenage years was a weekly trip on Sunday down to Kelham Island Museum. Fascinated by the River Don and the Crossley gas engine and learning as much as he could from the engineering staff and visiting ex-steelworkers from the mills, it sparked Greg's enthusiasm. After leaving school and still regularly visiting Kelham, he also built up a friendship with the staff and embarked on a project to produce a technical drawing of the 12,000 horsepower River Don engine. Richard Gibbon, head of engineering down at Kelham, lent him the book with all the diagrams of the engine parts. And we don't know where that book is these days, do we? Which is a pity. When the project was finished, it was presented to the Lord Mayor of Sheffield. And at that meeting, all his family were there with the Sheffield Star on that day. In 1989, Greg went into Parkwood Art College in Sheffield to study art and design. He obtained an NVQ in Auto Cad and then onto his H.N.D. at Norton College. Out of the blue, he received a phone call from a small games company in Sheffield offering him a job. He really enjoyed the work and found like-minded people to work with. He also got the chance to work with the game pioneers and learnt to use 3ds Max, which is software, which helped him to produce the virtual model for the Kelham Island Museum of the River Don engine, which he will talk about tonight. After leaving the games industry in 2012, Greg became a self-employed artist and went into producing a large range of illustrations depicting Sheffield past and present, which is on sale in the local gallery and museums throughout Sheffield. He also designed the mural for the Special Olympics held in Sheffield in 2017, which was displayed on Pond Street. He was also invited onto Radio Sheffield to talk about creating the mural. Greg also sculpts, makes models, as well as volunteering at Kelham, which he does every Tuesday. He also volunteers at the Low Edges Community Centre, supporting the craft. So you can see Greg's got a very, very wide range of experience. And again, Greg, we're delighted to invite you to give your talk tonight. Thank you.
Well, thanks for all coming to my talk. And I'd like to thank the people that are online listening. Hope you enjoy it.
The microphone won't give any additional volume in the room. The microphone is for the people online. So it's turned fully for the people online.
Yeah.
Speak up a bit.
Can everybody hear me? Yeah, brilliant. So thanks for coming tonight to listen to this talk. I hope you all enjoy it. It's fantastic to be here actually, because it feels like a second home for me. And as David says, the first time I came to the museum was 1982. That was the first visit to see this wonderful engine. And the second time I went with my mum and dad and my sister, and I got totally hooked on and fascinated by the River Don engine. So looking at the first slide, this is a couple of adverts from Davy Brothers Limited. The company actually started off in 1830 with three brothers, David, Dennis and Joseph. So they started off on Pear Street, I was told, in 1830. Between 1847 and 1852, they moved to the Park Iron Works, which I'll show you on the next slide. So this is the Park Iron Works in Sheffield. This is where the Riverdun engine was built. And I think there was around about 400 people that worked at the company. Sadly, it's no longer here, but it was actually on Folly Street in Sheffield near Norfolk Bridge. And as I say, from 1852 to 1921, Davy Brothers were based at this company. In 1921, Davy Brothers moved to Darnall. In around 1937, they became Davy United Engineering. They merged with the Pittsburgh company. So going on to the next slide. This is Mr. John Capron, born in 1859, died in 1937. Now he studied at college at the he was educated at the Wellington College. He entered the King's College London for 3 years and gained the James Easton Award. So in 1899, he went to work at Davies and became the manager. And then a year later, he became the managing director. He had a long association with Davies for about 30 years. So he actually lived in Haversige near Sheffield. Now, there was another chap actually who worked at Davies called William Warren. William Warren was a foreman at Davies, and in 1903, he actually was told by Mr. Capron, that he had to work on this large mill for Cammell Lairds. And he actually missed his cousin's wedding because he was in charge of the castings, being the foreman. So Mr. John Capron promised him 5 shillings to give to his son Tom and his wife Betty, who went to the wedding. And Tom, William's son, actually became a fitter at Davy Brothers Davy Brothers Limited in 1905. As the First World War came up, Tom served in the war in the trenches and actually was one of the lucky few that came back unscathed from not getting injured and embarked working back at Davies. He actually retired in 1955, but he wrote this article. It was actually in a Davies magazine, and there's a gentleman in the audience who I have to say a big thank you to, called Mick Steeper, because Mick Steeper gave me a lot of information about this engine. So there's a lot of people that I like to give credit to. John Capron actually died in Haversige as well in 1937. So he left Davy Brothers in 1931. We'll go on to the next slide. So as David mentioned, I borrowed a book from Kelham. I was 17 at the time. And you think, well, the engineers put a lot of trust into me borrowing this book. I don't know what's happened to it, whether it got damaged in the flooding. I've no idea, but this is one of the diagrams from the drawings. This is the crank housing for the bearing blocks for the on the engine. So we've got if I put the mouse along here, you could see that these are copper strips that are going along the bearings, the zinc alloy bearings, and at the top, the bearing block, I've got an oiler feed. So these caps have gone now. So there's 4 bolts that are just nuts that are holding it down. The plates, the cast iron plating is about 2.5 inches thick. So going on to the next slide. So I don't know if you can see this properly. This is actually a cutaway of the cylinder. It's a double acting cylinder. So we've got a steam porthole at the top there where the steam feeds through down to push the piston down. And there's one at the bottom to push the piston back up. So that's the cutaway. And these are all the drawings that I had to work from doing doing the engine. And because I'd been going to the museum a lot and just looking at the engine, just memorizing everything, because to be honest, I didn't have a camera back then, and cameras were a little bit crap anyway. So everything that came out were just, all the shiny bits came out and nothing else. In fact, to be honest, even when I went down with my mum and dad, my mum nearly jumped out of the skin because someone had a flash camera and she jumped back because she thought something was flying off the engine. She used to say, "Oh, I don't like that engine, it scares me." It's expecting something to fly off. So yeah, that's a cutaway of the end cylinder. This top one here, this is the top view of the cylinder, and behind the cylinder you can see the valve chest. So you can see the entablatures that are holding the cylinder up with the bolts there, the 4 bolts. And I don't know if you can see that. It's the bottom of the A-frames with the flanges. And this is a throttle valve. So it shows you the throttle valves are actually connected up. If you can see the dotted line, the throttle valves are actually connected up there. And you've got 2 safety valves on the top, one at the bottom and one at the top. So on the next view, we're looking at the conrod, or connecting rod as some people call it. And again, one of the engineers was actually making a model of the engine, chap called Denny. And he actually made the connecting rod, and he made the A-frames. You can actually see part of the model as you're walking into as you're going into the viewing platform in the museum. So as I say, I was just working from these drawings. I always remember doing the drawing actually, and the first time I did it, I was on my training course. This supervisor said, "I hate to say it, but it's all wonky." Oh, could have throttled him. Because I had to draw it all again, and it was all the side where you see the 3 cylinders. I put all the Delvac oiler boxes in, and I sort of realised the importance of using a drawing board. I also found, I also realised because I was using these pens the way to work from top to bottom, because if you're going bottom up and moving the slide rule up, you just get a blotch of black, which I'm not going to go into because I'll start going into all when the art teacher. So here's another shot. This is part of the valve gear, the links on the valve gear. So we've got the vibrating link, and we've just got a cutaway showing the inside the bear. I think there's actually brass copper stripping, but it's this is the links that you see at the front, and then this end one's connected up to the com rod, and this one's connected up to your valve lever, where it's connected up to the anchor rods that are connected up to the reversing arms. Sounds like that. Leg bones connected to the. So this is a drawing that I actually produced. So I've forgotten how long it took me. It took a long time, and this shows you some of the parts that are cut away. So you've got the spokes, the drive wheel. There's 93 teeth on the drive wheel, 23 teeth on the pinion wheel. As I say, the casting is about 2.5 inches thick. At the top here, we've got a dead weight valve. So we've got hydraulic fluid that's keeping this weight up at the top. It's a ton weight. just to make it keeps the engine going, which I'll explain a little bit more later on. So a lot of people want to know how the reversing works, and at first I thought, yeah, it's a difficult one to explain, so I'll try and do a diagram. And just to give you an indication of how fast it ran and rolled a plate of steel. Imagine a plate of steel 26 inches thick down to 2 3/4, rolled in 9 minutes. So that's 33 passes through the mill. There's 640.7 tons of steel rolled in a day, the River Don engine. So it just shows you how incredible it was. It still is. So this is how the reversing works. So if we look at figure 1, we've got steam that's been introduced to the top porthole, because it's a double acting cylinder with 2 portholes. So the steam's introduced to the top porthole, which I'll just point up there. It's pushing the piston down. There's about 100 tons of steam pressure in the steelworks, and it's exhausting the steam out from the bottom. And it's as it comes up on its upstroke, it's steam's pushing the piston up through the valve chest up to the cylinder and pushing it out. So when the operator, when the driver is actually reverses the engine, there's about 1,000 pounds of pressure, oil pressure, that's pushing the cylinders back and forward. So as we're looking at the figure 2, when the arms come over to the vertical position, it artificially raises the valve gear out of sequence. So it's blocking the exit route. So the steam can't move. So it stalls the engine when the arms come over to the resting point on figure 3. Can't talk. The steam, the porthole's open, so it pushes the piston the other way. So it does it in 2 seconds. It's in flat from full speed. So you've got the momentum of the engine, and it's the same sequence happening in the 3 cylinders. So it was David Joy who invented the joy valve gear, born 1825 and died in 1903. I think it was around about in the 1870s when he invented the joy valve gear. Davy Brothers actually got the license to use it. So a lot of rolling mill engines use this valve gear because it's important that you've got an engine that can reverse very quickly, because speed's essential. You've got the plate of steel cooling down, so you've got to reverse. It's, as I say, it's not very economical because it uses a lot of steam and it's a guzzler, but it does the job. So if we go on to the next slide. So, of all places, I got this poster from eBay. And I know. And this is actually another Davy engine that was built in 1905. And this one went up to Middlesbrough. And this one was rated at 16,000 horsepower. It still had the same boiler pressure, 160 psi, and the same speed, but the cylinders were 4 feet in diameter. The engine that we've got at Kelham, the 40-inch diameter, so it's a bit wider. But if we look on here, we've got a rev limiter on the engine. Now, a lot of these high pressure engines had a tendency to overspeed. So it's important that they had a safety device on it called a rev limiter. So what this rev limiter would do, if it overspeeded, an arm would come out and trick this lever here, and the lever was connected up to the dead weight valve. It would release the pressure. That weight would drop down and shut the engine off. So we've still got it on the River Don engine. It's just boxed up. So that weight, the weight on the top, it's a ton weight. And this is a diagram of the rev limiter, as you can see. Can't really see the top of it, but you've got the spring where the arm comes out and catches that lever, and it's a centrifugal force when it's overspeeding. As I say, we get the engine up to 90 RPM in the museum. In the steelworks, it could do 120. You've got 100 tons bearing down on each piston. As I say, it stops the engine getting damaged. Now, this photograph's wonderful. I love this photograph because it was taken in 1913 and it's on the Historic Engineering, Historical England website, sorry. And this shows you the engine, how it was at Cammell Lairds. So this is actually the front of the engine. So as you're coming in, you're looking at the back of the engine. I'm sorry, it's not very clear, but we can see the brass plaque, the maker's plaque here. And this is a Henry Berry compound pump hydraulic engine that probably would have pumped the water through to hydraulic cylinders to move the arms back and forward. There were 12 boilers, so I've been told, that powered the mill at Cammell, and they were all coal heated boilers. So you imagine the poor fellas are having to shovel the coal into the boilers just to keep the mill running. So yeah, that's a wonderful photograph. That it's I tried to actually get a larger scale one, but the software kept crashing on me, so I was a little bit annoyed about that. But hey ho, that's computers for you. So this next shot, this is at Cammell Laird again, and these were saying to John, actually, the guys wouldn't be standing this close to the billet as it was going through the rollers. So we've got a bit of artistic license from the photographer. But it shows you on the top of the mill, because the mill actually had 2 big screws to screw the top roller down. It was powered by a steam engine, and that's actually what Ted Turner wrote on the notes that I actually read, that Mick Steeper sent me these fantastic images and notes. And I have got, I mean, I'm sorry, I'm down sort of licking your boots a bit, Mick, but I do have to thank you a lot for all what the things that you sent me about the engine. The mill was actually widened when they moved it to the River Don Steelworks. I mean, it played an important role during the First and Second World War, rolling plates for the battleships in the Jutland War, and plates up to 16 inches thick were rolled for the King George class battleship. It could roll plates up to 80 tons in weight, 44 feet in length, about 13 foot wide. So moving on to 1957, the mill was transferred to the River Steelworks. It was up and running again in 57. It took about 6 months to get the mill back up and running. Now, Ted Turner, I think Ted Turner did these drawings, but we can see this is the size of the mill. And when I show it to visitors, because they say, oh, it's a shame why they didn't save the mill. I say, well, if you look at this diagram here, you can see why, the length of it. You've got, if I just use my cursor, you've got the pulpit cab that operated the mill from. So the steam engine that powered the hydraulics, that was gone. They electrified the screw downs. So the steam engine that operated the screw downs, that was gone. And it was I think apparently it was Davy United that electrified the screw downs. So they were involved. And you've got the mushroom buttons here. So if the plate of steel went off at an angle, it would actually square it back up. And you've also, the problem at Cammell was the buildup of scale underneath the rollers. Because you can imagine if you like just started there in your first job, right, lad, I want you to start, shoveling all this scale out from underneath rollers. We'll give you 5 shillings for your problems. So yeah, they put the pulpit cabs in, and the scale chutes where the scale was actually collectors. So when you're driving back home, taxi for me, when you're driving back home, you look on the road, you look at the tarmac, and it's all the scale and the steelworks that they're using on the tarmacking. Right, so this is the engine in situ at the Riverdon Steelworks, and the top, this top one here, I reckon that was taken in the 50s, because you can see how clean the engine is compared to how you see it on these. Now, the gentleman that took the coloured photographs was a chap actually called Peter Ellis, and he's a lovely fella actually. I got to meet him a few years ago, and he actually knew George Watkins, who wrote quite a lot of books on stationary engines. The stationary engines that disappeared because no one was too bothered. They were all interested in steam locomotives, and he actually took these photographs in 1976 because he was studying at the Sheffield Poly at the time, and one of the students was actually working at English Steel. So I used to tip him off to tell him what, when the engine was running, when it was doing a roll. So he used to go down with his camera unchallenged and take these wonderful photographs. Now, if you look at the bottom right, this tank here, these are the accumulators that are outside the the factory where they supplied the steam through to the engine. There was about 400 pounds of pressure of steam going through, and then the reduction valve that took it down to 160 to the engine. So I just got a. So these two shots here, they're actually showing you the pulpit cab, and the you can see the mill indicator. Now, there was a clutch system on the mill, so when the guys wanted to caliper the steel, they actually used to put the clutch down just to stop the rollers, and the guy would go out with his visor tied up with string to caliper the steel. So it wasn't a nice job, as what one of the drivers said. He actually quoted on one of the films, "I wouldn't want to do their job for all the tea in China." And it wasn't, because you've got to imagine you've got all the scale shooting down like gunshot, and it was very painful if you got it down the side of your neck. So there were 3 tons of brushwood. In fact, you can see over there's 3 tons of brushwood. There was also on the note that Ted Turner wrote that there was actually some a tannoy system where workers could talk to each other. I don't know if this is true, but it was told to use not to use bad language if any school group came in to visit. I was also told by one of the fitters, because I met one of the fitters in 2017, and we went to the steelworks, to the forge masters. Some of the guys used to squat themselves into the spokes as it was going round when they were doing maintenance. And there was also a guy that used to wear a skirt to work, and the bosses told him off and said, "You can't come in here wearing a skirt, it's not on at all, it's not on." And a few days later, he turned up in a kilt. So it's all changed a lot now. So coming to the end of an era in 1978, these are photos in the mill as it's closing, and the bottom. I mean, the coloured one, the colour photographs were taken by Peter Ellis again, and they were taken in 1976. I think it was the 23rd of May 1976 when he took these photographs. Trying to keep my brain active, because I always try and remember dates. So we have a lot to thank this chap for, Mr. Hugh Wentworth Ping. Mr. Hugh Wentworth Ping was born in York in 1924, He started his work for Vickers Stainless Steel Limited, and came to Sheffield in 1972 when he came across the River Don engine, and with all his cheek and charm, he persuaded them to not to scrap the engine. So he had to raise £20,000 in scrap value, and that's how much it was worth back then. A lot of money, and thankfully he managed to get the money raised, and we've now got this wonderful River Don engine. He became a sales manager for Vickers, and but then he moved to, as I say, in 1972, he moved to the River Don works, and that's where he came across the River Don engine. And I think there were talks about it being scrapped because it was taking up a lot of room. Where the engine was, where the fitter Stephen Barr told who was one of the fitters, he said it was a pattern making shop. That's where the engine was. And he was a lovely guy, Stephen Baum. I don't know if he's still with us, but he wasn't very well at the time. He got a little bit upset because when we went to Forge Masters, he was looking at the pumps that he was looking after, and he just shook his head. And someone said, I told you not to see the pumps, you'll get upset. Because he lovingly looked after these pumps. He kept them nice and clean. They're still there. They were made in the 1930s because they pumped the water through to the hydraulic presses. Because we were, as I say, we went round the forging shop and the machining shop, and he showed me where the River Don engine was. So if we go on to the next slide. So again, I've got to thank Mr. Mick Steeper again for these photos. Peter Smith first came to the museum in 1977 because when they got the money saved for this engine to stop it from the scrapyard in the Sky, they looked at several sites in Sheffield. Where can we house this engine? This big, enormous engine, and Kelham Island kept propping up. And so, because it was vacant at the time, it actually used to be a power station for the Sheffield trams. And I know when they were probing the flooring for the depth and the thickness of the concrete, they missed out a really hard part of the concrete, and they had a right job getting it out. But it goes, you can see the depth of it goes down about 18 foot, roughly there or thereabouts. But it took 36 hours to fill in for the foundations to where the engine sits. We'll go on to the next shot. So the next shot is bringing the pieces of the engine in. So if we look at the top left shot, you can see the crankshaft there. You can see the size. The crankshaft's actually hollow. I remember one of the, I think it was Jack from 1984, said to me, when the engine's at one position, you can actually look through the end journal, where the pinion is, and see right to the other end at certain positions. Because you've got 426 tons of iron and steel. So we've got this other shot showing them putting the A-frames in. You can see the housing where the drive wheel sits, and it's coming together as we've got this. You can see the crosshead to the connecting rod there. And the last piece that came in was the drive wheel. You've got 51 tons of drive wheel with its 93 teeth. And apparently the crane was waiting a while for the drive wheel to come in because the police weren't too happy about it, this big drive wheel being transported from Forge Masters to Kelham Island, would it come off, and how much damage it would cause. 51 tons, I mean, that's like the weight of a tank. So this is Richard Gibbons, who lent me the book. This chap here with the beard and the hard hat. And it just gives you a sense of scale, how big the conrods are next to a person. And yeah, Richard Gibbons, he left Kelham Island, I think it was about 88, 89, and went on to work at the National Railway Museum. And Richard Gibbons obviously was in charge of the restoration work. It was about 3 to 4 years of restoration work that took to get the engine back up and running. I mean, going back to the fitter, Stephen Baum, who worked at English Steel, one of his first jobs was to scrape the bearings on the engine. And it took a contractor 8 weeks to take the engine to pieces so they could get to the bearings. Because he had a job first as a carpet fitter, didn't like that. And it was the days when you could sort of walk in one job, and then if you don't like it, get another one. So this chap over here, that's Mark Potter. Mark Potter worked at the museum. He used to work on the ticket office. So yeah, last time I saw him, he was actually working at Bramwell Lane as a steward. So it's nice that they're both still around. So here's another couple of shots. You can see how the engine's all coming together. It's still got that green, they used to call it the big licorice sort, apparently. But when they stripped it down, they came across a dark green that you see it as it is in the museum. I think that's Richard Gibbons' hat, that actually. I think he's, because I think they used to go to a pub after they'd finished, you know, to Albion when it was before it was Fat Cat. We've got a lad on here. Apparently, when they were cleaning the engine, because they have like a day when they have a maintenance day, one of the chaps used to run up the drive wheel. Crazy. I mean, I've been on that engine. I'll tell you what, it's high up there. When you're going up onto the top balcony, it feels like you're in a greenhouse. It's the heat. It's tremendous. And here it is down at it all looking spanking new and nice and clean. And another bit with the restoration work that I should mention actually is when they took the gearbox off from the bed plate. There was a hole and there was a fire. I don't know if it was caused by a ramp or whether it was done on purpose or not, I don't know. But the next day, there was a massive bang. The bed plate split. So when they brought it in, they had to stitch weld the bed plate up. So it was a company from Rotherham, heavy engineering stitch welding company. So to get the engine starting, we fire the boiler up at 9 o'clock in the morning. And then at 11 o'clock, it's warm enough to turn over to get the moisture out of the cylinders. So 11 o'clock, the engineer will come on and start the engine just to get all the moisture out. Because we use a tanning in the water to stop the corrosion. And then it'll go up onto the top balcony and feed a gallon of oil through the cylinders. Right, when I was working in Spain in 2007 and my lungs were getting abused by 2 chain smoking programmers, and I had to listen to the games developer ranting about life and everything. The only thing I had to look forward to were the sunny skies in Spain, and it was a different kettle of fish because it was raining. It was raining and raining, and it was biblical. And when I was ringing home and telling them I'm fed up because it's a bit, I mean, it was actually I know I shouldn't slate Spain off because it's a lovely country full of lovely people, but where I was, it was like the good, the bad, and the ugly, and that's where they filmed it, the spaghetti westerns. So, yeah, I had, yeah, we had £1,000. Sorry, we had 1.5 million pounds of damage to the museum, and obviously the Riverdon engine succumbed to the damage. So if we can look at the top crank picture here, we can see all the rusting that's actually on the conrod and around the crank as well. So took 5 men, 100 hours of time of wiping the engine down just to wipe it clean, and they use a Brillo pad just to buff it up. You can see the chemicals that they're using there. So the buffing the conrods up here. I mean, thankfully, the bearings are greased, so it stopped the water from damaging the bearings, because obviously the grease acted as a repellent. And the extent of the damage, we can look at the paintwork now. There were 650 square meters of engine to paint, requiring 47 litres of polyurethane acrylic green paint, 15 litres of black paint. So after 8 weeks, it was painted by these. If I just go on to the chaps here, these 3 gentlemen here, they did the paint job. You can notice that there's none of the oiler boxes that are on the engine. They were stripped off. Everything was stripped down and cleaned up and polished up. So these are the oiler boxes, and I know for the ones that can't see this online, I've brought a hydrostatic in. It's on the engine, so there's 45 hydrostatics with a non-return valve at the top. You've got this glass case in here that shows you the glycerine chamber. So it's glycerine and water and other chemical additives. And people can look at it later on. There's a wire where the oil goes up and it gets sucked into the engine. So there's 45 of these hydrostatics that were on the engine that were taken to pieces, all buffed up and cleaned up, and everything was stripped and cleaned because it was obviously with a contamination. So this is the oiler boxes all stripped off or stripped down. So it just looks like one of them diagrams, isn't it, where you get in them car manual books that you can't. My granddad, actually, his neighbour, because my granddad was a fitter, his neighbour took his car to pieces and he couldn't get it back together, so my granddad had to put it back for him. What an idiot. So showing the oiler boxes with the, these are smaller oiler boxes. You can see the hydrostatics all looking, because they put the primer paint on first and then it's all buffed up nice and clean. There's 40 greasing points on the engine. So when they're doing the greasing, just imagine 40 points that the engineers have got to grease. So this is showing the piping, the brass piping and the non-return valve all in pieces. So it's got the spring and the bearings, and it's got a saddle where the bearing sits. So it stops the oil feeding back into the oiler boxes. It was actually the oiler boxes were retrofitted. They weren't an original feature on the engine. On to the next one. Right, I don't want to scare anybody, but one thing I noticed on number 3 cylinder, well, it's the first one as you're walking in, on the conrod, there's a little bit of scarring going down here. So in the left-hand shot, it's showing you the large ladder that's going down the conrod, and on the crankweight, the one nearest to us, there's also a chip. Now, what happened, and this is what Bob told me, one of the engineers, because Bob, who's retired now, used to work at English Steel, and but one of the pins came out of the links because the nuts aren't tied on mega tight. There's got to be a little bit of place so the rods can actually sort of move about. But one of the pins came out, and the link was actually one of the links was actually frailing onto the conrod, and it caused this damage. So they actually straightened the spindle out on the link, and when they're oiling it, it requires a little bit more of attention to it because obviously it seeps through, so it's straight enough. So in 2016, moving on, we had a lottery grant and we had a new boiler. And I was also given a bit of money to get my animation moving, because when I did the virtual 3D model, it was a labor of love. And because my boss was saying, you need to get your head around this 3D program. And I looked at it and I thought, oh my God, how am I gonna get my head around this? Because there were no YouTube back then. I was always pestering the other artists to, how to use the software. But this is a render from the 3D model, which I'll, if you want to see, I can show it you. And this took about on and off about 12 years of work. Because to be honest, I mean, there were times when I felt like giving up on it because we're trying to get it. I remember sort of trying to get it into the museum, and it was just obviously getting it was just the timing. And I'd only done the engine. I think when Mick Steeper saw it in 2009, it was just the engine, and it was all done from here, not from looking at the drawings. It was all from my noggin. So I'm brighter than what I look. So we need to go on to the 3D model. Can we? All right. So. Yeah. We apologise for this interruption, but the programmes will resume shortly. Got to put tap card on. And it's that one with the snaky.
So we're going to get the snake there.
Yeah, yeah. Oops. Click on there. Just,
you drive it.
yeah.
We'll get this one going. That's it.
Right.
What we're going to do is we're going to get that into Zoom.
Right.
Fingers crossed that should be it.
Yeah. Well, thanks for joining back with me. Hope you found it riveting. Did I? So, yeah, going back to 2001, I had to try and get my head around this software, and I thought, what shall I do? What shall I do? What can I create? Because I needed to do something I could get my teeth into, and I thought, you know what? I'll have a go at making a Rivedon engine. What an idiot. Yeah, I just thought, why? Anyway, so it started off looking very basic and rubbish. I mean, we just finished working on ET, and like David mentioned, the pioneers that I worked in with the games industry were, I mean, we're going back to guys that worked at Gremlin Graphics. We had two brothers that worked at Gremlin Graphics, and to be honest, they were like chalk and cheese. They nearly got into fisticuffs one time, and brought me into work on ET for the Game Boy Advance. And to be honest, it sucks. The game, it's the worst, one of the worst games that's out on the Game Boy Advance. This review, I was looking at the reviews, it's like lameendings.com. It shows you the animation scene that you know, and ET's going into his spaceship and he's waving to Elliot. And some reviewer, some American reviewer, put, "This game sucked so bad, I flushed it down the John." Another review, after playing this for 12 minutes, I lost the will to live. Right. My boss actually did apologize, as I'm sorry that your name was on the end there. There was another one that said, "Looks like ET's flipping the middle finger at Elliot." Honest, that's honest truth. I mean, the ET version for the Atari was so bad they actually buried it in the desert. We worked on quite a few crappy games, but you know what? The people that I worked with, they're absolutely wonderful. Mark Cooksey, he actually did all the music for a lot of the big games like Paperboy, Sports, Ghost and Goblins, and I know this probably doesn't mean much to you, but I mean, I don't play games anymore because I actually had to test these games, and I'll be honest, I thought, God, it's like pulling teeth testing some of these games because you've got to test them for everything. But yeah, I always remember the day because it was a day when I started working on this model on a serious note, that it was a day that the world changed because a friend and colleague came into the office and said, "There's been a plane crash in America." And of course, it was 9/11. So I always remember the day when I was actually working because the publishing company that was publishing ET was actually not far away from the World Trade Center site. So this software that I use, as I say, we can sort of build models. It is like SolidWorks, but you can actually put texture and lighting on, and you can actually create shadows as well. So when you render the scene out, you can make it look more realistic, and you can actually stick in a little bit. It doesn't run quite as well as the Riverdon engine, but it did. I was up animating one of the parts, the connecting rod with the links, from 9 o'clock in the morning till 5 a.m. next day. No sleep. But to be honest, I mean, when I was working on the games, I did a 21-hour shift without any sleep. And I'll tell you what, don't ever do it. It's not good for your health. So going around the engine, we can zoom up to parts that you can't see. I'll just stop it. Sorry, my arm's gone to sleep a bit. So I'll put all the oiler boxes on, and you can walk down the engine and turn it around to every angle that you want to choose. We can look at the other side of the engine as well, with all the pipe fittings. And if I just move it up, so it did take a long time because, as I say, it all came up from the head. And when my boss saw it, he said, "You sad git." Yeah, I thought we were going to say, "Oh, it's wonderful that." No, it was like, "You sad git." Oh, thanks, Nigel. Oh, thanks for that. You're welcome. So as we're coming through, you can sort of go around the mill. You can see. So it's not just creating the engine, it's creating the whole mill. And this is why I've got chaps like Peter Ellis, Mick Steeper, Stephen Baum, Richard Gibbons, my parents to thank for, because I'll be, as I say, to be honest, it was like, the reason why it took so long is because it's the time putting into it. It's made up of 2 million polygons, which is a lot to hold. It took about 7 hours to render the short film out that you see next to the engine. It's like someone saw it, said, "Oh, it's a bit short, that." I said, "Yeah, it took me about 7 hours. The laptop, the steam was coming out of the laptop when it were." But yeah, I mean, someone else said, "Oh, why didn't you put the blokes throwing the brushwood on?" I said, "Well, okay, then if you can know how to rig up a person and put the animation, and there's a rude expression called boning a figure, because that's what we do when you're creating a figure to animate. It's you're boning the figure up, and that's a job in itself. But as I say, I didn't work from any drawings. It was all up in the noggin. So I am, I'm really proud of this, because it. some people go up and they just have a quick look and it's like look away, and you just think, for all that time and effort and energy that went into building this virtual model, because it's not just creating it to look realistic and getting all the parts right, it's also getting the feel and that sense of how it looked in the steelworks and the shadows as well. Because creating the shadows, I know you can't really see it on this model, but creating the shadows was important, because the thing is that SolidWorks is more of a program for building engineering models, but 3ds Max is it's the same company, but they build the Max for making games. 3ds Max is for making games. So it's it was not just getting my head around it, but it was learning to animate as well, because that was a thing in itself. And you can actually, if we can sort of select a part here. Oh, stop. I'll just put it onto perspective. So you can set cameras up as well on the software. So, and you can actually move the cameras around. But so, oops. This one. No, at all. So if I just try and click on a comrod, you can sort of just show one part at a time, which makes life a lot easier because when you've got so many parts to model, you've got to animate it. You can hide the parts, and you can sort of, so animating it was done one frame at a time. I'm sure there's probably an easier way. Probably I know one of the guys always used to say, "You like to do stuff the hard way, don't you? You like to do it the hard way." I said, "Yeah, I've always been like that. Glutton for punishment." So it's just saving at the moment. This is the worst part, when it starts saving, because you have to wait. It goes on and on and on, and you have to Blake 7 there. Yeah, I used to watch Blake 7. Remember it, 1978. Gareth Thomas, still saving. Oh dear. So yeah, the model itself, it's people say, "Why did you do it?" And I just said, "Well, it's an important part of my life. because it molded me as a person, and it helped with my confidence, because to be honest, it's like when I met Mick Steeper in 2009, I wouldn't have been able to come up and stand in front of you and do this talk, and I hope you've enjoyed it. I'll be honest with you, I was absolutely, I'll not say the rude word, but I was sweating, scared when I started it. But no, you've been an absolutely wonderful audience, and I hope you found it interesting as well. And thank you so much for coming.
We've got time for a few questions, if we've got any. That's all right, Greg.
Yeah, I'll try and answer the questions.
People online, if you want to put questions on chat as usual, I'll pick them up, either relay them or put you on. Do you want to-
I think I've got a loud enough voice.
Yeah, yeah.
Can I preempt one of the people online? We discussed this before.
Yeah.
Dealing with the very intermittent steam loads. You've got an engine that works full tilt, then stops.
Yeah.
And these boilers are going full tilt either at
Yeah.
Cammell's or at Riverdon.
Yeah.
How on earth does the steam system cope with those massive fluctuations in demand?
Yeah, well, like I say, outside the building of the Riverdon Steelworks, they had 3 accumulators outside to store the steam. I was told there was 10 gas boilers at the Riverdon and 12 at Cammell Lairds. So the guys that would have been absolutely really busy stoking the boilers. I mean, we run it on 100 psi. It's about 140 quid a day to run that engine, there or thereabouts. It goes up and fluctuates the gas price. Obviously, with Mr. Putin, Putin's war doesn't help matters. But as I say, as engines go, it's not very economical. But it was built for its purpose of rolling armour plated steel, and you need an engine that can reverse very quickly. It did actually, when it reversed the engine, you could see sometimes the steam coming out of the stack would actually suck it back in, suck the steam back in like a vacuum. So I hope that's sort of answered your question.
It's more a comment on the last question.
Yeah.
And I understand it when the engine was first fitted.
Yeah.
Its own boiler.
Yes.
But around about 1915 or so.
Yeah.
Perhaps a bit before then. The Grimesthorpe works actually fitted a joint boiler which provided steam for the whole factory.
Yeah, possibly, yeah, probably, yeah. It's
so I think that helped a lot.
Yeah, I would imagine. I mean, the thing is, as I say, it's sort of, I mean, there's a lot of, it'd probably be one for another lecture, because there's something that I'll have to research about the Grimesthorpe. There's the problem. I always remember going to an art exhibition in London in 2003, and I went to see Andrew Lloyd's art collection, and there were some wonderful pieces of artwork, and some of them were rescued from skips of all places. So a lot of history documentation, drawings like this, and my friend David Hinchcliffe will echo me on this, that they were thrown away, you know, stuff like that. So I'm probably assumed that it would have actually fed through the other factories, because I know for a fact that when the engine was at the Riverdon works, I was talking to a chap who works on the hammers, and he used to get annoyed when they were running the engine because he used to nick the steam from the hammers, so they couldn't get the pressure up. And he didn't like the engine itself. It just called it a big green lump. Disrespectful. I don't know.
Greg, I can come down a bit more 1974, I worked
Yeah.
on the construction of the new foundry.
Yeah.
The old seniors building.
Yeah.
And I seen the engine run. From memory, that one of the big problems at Riverdon was as follows. They had two power stations, north and south power station. Now, at the time, we were extensive altering the steam pipework, and memories that one of those stations, and I think it was the south power station, was shut down and abandoned. And that there was a plan to abandon the north power station as well, and go over to mains power, but the whole of the works.
Right. Yeah.
Now, the situation was that by 74, there was only enough steam to run it if they didn't generate at the same generate power for the arc furnace at the same time as running the engine. So it only could be run intermittently when they got things down. Hence why there was a lot of Saturday rolling, and they were rolling for the North Sea oil.
Yeah. Yeah. Yeah.
Question at the back. Yeah. I've got one in mind. All right.
Thanks for that, John. Anyway. Yeah. If you could email me that, because that would be another. Yeah, that would be another interesting sort of fact for my collection of the information on the Riverdon engine. So, because it's always great if you can meet people that worked on the mill, and I did meet a lot of people and get a collection from their memories. But sorry, sir. Yeah. Yeah. Well, they were cast, but they actually was machined at another company called Scott and Hodges, because I was looking on the notes on the drawings, and it said gear wheel teeth to be cut at Scott and Hodges. So it was another company that cut the teeth, and they were machined, but they were. I mean, one of the most skilled jobs was a pattern making job to when they were building the the A-frames up, and it was you've got some pattern as you're going into the museum. You can see some of the pattern making, and I watched a really interesting video, and it was actually in India where they were making a gear wheel, and it showed them all wearing the sandals, and no health and safety was out of the window back then. So but they actually used these blocks, and they were pushing them up to get them as tight as possible for the casting, and poured it in, and as soon as it set and they started breaking all the sand casting moulding off, they actually machined the drive wheel to get the teeth properly done, because it's, as I say, it's important that you've got, it's always the thing, the inertia that you've got on the engine, because it's all about torque, the engine. It's not about, it's, I mean, I got trolled once on YouTube, and just thought I wanted to share some information, and this guy said, oh, you're waffling on about something that you don't know anything about, blah, blah, blah. And he was always like referring to Grace's guide, saying the engine runs on 5 psi, not 100. I said, no, it doesn't. It runs on 100. You can turn it over after a bit on 5, but it's only once you've got the momentum going, because you've got 100 tons of steel moving up, turning round. You can't turn it over on 5. You can't run it on the speed that it does, because we run it up to 90 RPM in the museum. So yeah, I mean, the teeth, as I say, were machined at a company called Scott and Hodges, if I've got the names correct. Hodgson, that's it. Scott and Hodgson. Yeah. Right. Oh, thanks for that, Mick, anyway. Yeah, yeah. Yeah. I wondered about that. I always wanted to know why it was machined at another company, and thanks for sharing that with me, Mick. I really appreciate that.
I spent a long time in my work not dealing with very large aircraft, running, building, repairing, etc. And when I came to Sheffield and found what they had at this museum, I was astonished that they could run it. And I'd be interested, do you know whether it is a very onerous burden on
it does swallow a lot of money, because they say it's about 240 quid a day to run, and they went through one stage. I mean, I remember, and this is another gentleman that I like to praise, is John Hampshire, who came to the museum in the 90s, because I remember it was on the verge of closing. I remember when they used to run the engine every hour on the hour, the gas engine was running on gas, because the smell of the gas as you walked into the museum, they had the no smoking sign. The family came in once, and this lad said, come mummy, don't half smelling here. And she said, yeah, just like your bedroom. So yeah, the burden of like running it's I mean, we only run it for about 2.5 minutes because it exhausts the boiler, but it's as I say, with the gas prices going up. I mean, I was quite sad that they stopped it running on Tuesdays and Wednesdays, but I could totally understand why they stopped running it on Tuesdays and Wednesdays, because of cost of it's a main attraction of the museum. It's the object that people come far and wide to see it run. And I've got to say that, you know, in the days that we're living in today, in a throwaway society, it pays tribute to the guys and the engineers that built this engine, because they built it to last. If we can get the engineers that are passionate about the engine, and after my lifetime, it'll run for another 100 years.
Great, there's 2 questions online.
Sure.
Chris Homer is asking, do we know the date when the engine last rolled? What year did Mr. Pink raise the funds to preserve it? We've got a comment from somebody called Robert. George Watkins was a member of this newcomer, so we have a lot to thank him for. We do.
George Watkins, as I say, my friend Peter Ellis knew George Watkins, because I think from what I remember is that he had a little flat in Rochdale, and he went round photographing all these engines that were disappearing, and I've actually got a few books that he did. He's actually got one of the gas engine, the cross lane, because that stopped working in 1970 down on Penistone Road. But I think they probably would have kept it as a backup just in case the electric motor mill that was rated at 400 horsepower broke. I don't know, but it's good that they've saved it. But the date that I can say, I mean, Peter Ellis put down, I think he put down 26 of May 1976 ? But on the film, I know it was 1978 because that's when the film was made, and that's when the curator says, you know, the mill closed after this final roll. So I'm sorry, I can't. I'll try and find out if I can. I mean, maybe Mick might. Do you know at all, Mick? Yeah. Yeah. So it's as I say, we'll try and find out anyway. No, it's okay. Yeah. The only break that the engine had was the dead weight valve, just in case if the engine overspeeded, because it's all throttle driven. You've got a steam servo at the bottom, so sometimes when the engine's running, you see a tank. There's a tank at the bottom. It's a separation tank, and it separates the oil from the water and steam starts coming out, there's a tap on the steam servo that operates the throttle. If you switch it off, it stops the steam exhausting out. But it's no, there's no stop on it. There's only the valve that the operator turns off to shut the steam off.
Gareth Roberts, who was Vice Chancellor of Sheffield University, when he started operating, and he was he's a physicist.
Yeah.
So they defied the laws of physics.
Yeah. There's tell you another little funny story actually, because I met this chap from the steelworks that told me about the guy with the skirt on, because his first job was he used to say, right, I want you to get into subs and I want you to grease the bearings. So he did it with a big brush, and he used to say, right, we're starting it up now, starting it up just to see how fast he could get out. And that's what he told me. So I mean, it's great when you meet people that worked on the mill, because I've got every respect for them, and you know, it's great to be here. You know, I thought it were going to go all Pete. No, thank you, thanks so much. You've been a wonderful audience, and I hope you have a safe journey home, everybody.
Thanks, Greg. Thank you. A short vote of thanks.
Yes, Greg, on behalf of the branch, the 40 face-to-face attendees and our virtual friends on Zoom, 131 in total, yeah, which is amazing. Yeah. Yeah, well, I'm sure they've enjoyed this, you know, sort of fascinating talk that's taken you through 40 years of your life, you know, from boyhood fascination through a career in games, and the research work that you've done, that's obviously a combination of engineering and also discussion with people that actually worked on the engine, which gives you this unique fund of stories that can add humor to and enhance the presentation. I think that what I've found is that it stimulated my interest, which is in the mechanical engineering background of Davies and their history, right through your volunteering at Kelham Island in order to, as I say, produce this, you know, fascinating talk. And I think that everybody here has enjoyed it.
Yeah.
And we'd like to thank you very much in the normal way.
Yeah. Well,
thank you very much.
That John's going to give.
Okay, I'll go through this as quickly as I can do, conscious of time. Next meeting is, I can't see this, it's so dark. Next meeting is on the 30th of October, when we have Jonathan Ayling, who's just snuck out the back, I've seen, to catch his train back to Manchester, I presume. It's going to talk about the RAF planes that won the Battle of Britain were built on German machinery. Why the Jewish refugee engineer Ludwig Louvery was crucial to Britain. Now, I'll give you a sneak preview on this. I've known the story for 53, 54 years. Apparently, we had a buying operation in Stockholm. We used to buy brand new German equipment, ship it to Stockholm, strip it down, and fly it over here. It's a fascinating story. I've known it for a long time. I've actually seen one of these machines. It's well worth coming to listen to if you like things. On the 20th of November, we have an afternoon and evening meeting where Jeff Horseman, remember Jeff from last year, is going to do the other half of the NEI Parsons story, which is the Parsons gas turbines. So in the afternoon, he's talking about really the first industrial gas turbine that they produced, and then looking at the application of that at the Dunstan A, which is the first production power station in the country. 7th of December, we have RAF Finningley in the Cold War. And then on the 22nd of January 2024, we're going to try something totally different. Back in the dim and distant days before COVID, the last lecture given in London before shutdown, and we moved online, was by Michael Eckhart. Now, I've met Michael on I think 3 occasions now. He's a lovely guy. He lives in Munich, and he was a researcher at Deutsche Tech Museum. And what we're going to do is Michael is going to stay in Munich. He's going to talk online. We're going to stream him here on the projector onto the screen. He'll also be available online, but he's repeating his lecture he gave, the last lecture he gave in London, which, to be honest with you, was only about 4 or 5 days before shutdown, and not that many people attended. So it's a rerun of that. It's well worth listening to. February, we've got Michael Bailey. This is another important talk on the development of steam locomotives in that critical period, 1825, 1830. Barraclough lecture in March, and then a lighter one in April, when Phil Judkins, most of you will know, is going to talk about the experimental work done at Sherburn in Elmet. If you think a Jeep can't fly if you bolt a pair of wings on it, come along in April, you'll find out differently. And then at the end of May, to wrap everything up, David and John Anning are going to talk about Bessemer steel production in Rotherham, and in particular, the steel bakers of Rotherham. Thank you, everyone. And I hope so. Want to see you all again in 30th of October.
Yeah, thank you very much indeed for attending.
Thank you.
Before you all go, can I just make this short?